Okay, I'll just start with a quick introduction. My name is Ron Hamilton with PTP. I've been with PTP for about 11 years, a little more than 11 years now. If you can't hear me in the back, just let me know, raise your hand or something. I've been hacking web applications for about 25 years, and if you do the math on that, that takes us back to NCSA Mosaic. Anybody want to venture a guess as to the screenshot up there? Any guesses? No? So that is the world's first web browser from the inventor of the World Wide Web, who is, anyone? Anyone? Who invented the World Wide Web? Al Gore? Do not say Al Gore. So Tim Berners-Lee, that's the very first web page in the world on the very first web server. How about you guys? How many of you have used a proxy such as Burp, Zap, Peros, whatever, to test the security of a transactional web-based application? Nobody? All right, good. You came to the right place, because this is an introduction on how to do that.
Yeah, WAF. We have Web Application Firewall.
Right, so Web Application Firewall would be tasked with trying to identify the vulnerabilities that you would be testing during an OWASP-style web application test. So that's what we're going to talk to, how to manually test your transactional web application. So this is just 45 minutes, so essentially what we're going to talk about is a popular tool called Burp, how to use it, where to get it, how to configure it, the very basic use of it. You can use Burp, you can use Zap, you can use Peros, there's half a dozen tools out there. What we're not going to talk about is, what is SQL injection and how do I deal with that, so forth and so on. We're really just going to kind of focus on the tool and how to use the tool and how to set up a little testing environment of your own. So if no one here has ever done that, that's good. You came to the right place. Our goals are to get you, how many of you are software developers? Okay, good. So we're kind of geared towards software developers or information security officers that, maybe you need to hire someone to do an independent test of your web app and you want to know whether or not they're doing a good job, do a little work yourselves, or you can test the app internally. So, we want to get you putting your hacker hat on and thinking like a hacker and understanding how these tools work. And feel free to interrupt me throughout the presentation. I don't mind questions, raise your hand, blurt stuff out. I don't care. So I used to have a lot of disclaimers at the beginning of these presentations, 10 years ago. But we now live in the world of bug bounties. Anybody not familiar with bug bounties? Okay, so 10 years ago I'd start this presentation by telling you the tools that we're going to go over and the methods that we're going to go over in this class you don't want to do at home against Wells Fargo. You don't even want to do it against your own agency or your own employer without explicit permission from the CISO. So that probably still applies, I would think. But there are literally hundreds and hundreds of companies now that have what are called bug bounties, and essentially you can go to their website, you can do the things that we're going to show you today, and you can hack them, right? You can hack Uber as long as you operate within their rules of engagement that they have posted on their website. Sign up for an account, agree to their rules of engagement, and you can have at it. You can practice all of your web hacking skills against live, real websites. So not too much disclaimer needed anymore. Just, don't go hacking people that don't have bug bounties, please. So how do you set up to perform a web application test? Well, first you're going to need a few tools. The one that we're going to talk about today is Burp, but Zap is equally as good. A lot of these tools like Burp is actually forked, so they have a free version, so you can get started without paying anything. And you get all of these from the OWASP website, OWASP, with the exception of Burp, which comes from the Portswigger website, but you can just Google any of this stuff. Burp proxy tool will get you there. And it's from Portswigger. You can get the free version. So you need Burp, Zap, Fiddler, the proxy of your choice. Then you need something to hack. So go hack Uber, or you can download a couple of different insecure apps. So these are apps that are written deliberately to be insecure that you can test against. The two that we usually recommend are WebGoat and Security Shepherd. They're both from OWASP. And other tools you might want to consider are like the developer toolbar, by Chris Petterick, and there's a link for some other tools as well down below. One of the nice features of the web developer toolbars, one of the things that we use it for the most, for example, is turning a proxy on and off. So everything that we're going to do is through a proxy, which means our web browser is set up to proxy, and you might have occasion to want to turn that off. You know, maybe you want to go back and do some real work and you don't want everything going through the proxy, or just use two different browsers, which is what we recommend. So with all of these tools installed on your machine, you're going to have port collisions. And what we have up here is the recommended configuration that we use for avoiding those port collisions, because all of these tools tend to default to port 8080. So we recommend just leaving your proxy at 8080, which is the default, and then setting up your target to be on some other port, 8081, 8090, whatever port you want. Just make sure they're all using unique port assignments. And this is what you're setting up. So in this diagram, you've got your browser, Firefox, over there on the left, or whatever browser you want to use to hack. It doesn't matter too much which one. Your proxy is going to sit in the middle, in between your browser and your target website that you're attacking. So that could be Uber up at top. You could have WebGoat on 8080, and you could have Security Shepherd listening on 8090, or whatever port you choose. So is that all pretty straightforward? And then what I usually like to do is pick an alternate browser, such as, so if I'm testing in Firefox, I want to do all my research and actual web browsing in something else, usually IE or Chrome. But just be aware of the fact that if you decide, hey, I think I'll test in Chrome and just surf the web in IE, understand that Chrome and IE share proxy settings on a Windows operating system. So as soon as you set Chrome to proxy, IE picks up those same settings and it will proxy also. So be aware of that. There's ways around it. There's a little switch back here on the previous page that will get IE to not use, or rather get Chrome to not use the IE proxer. So if you really like Chrome and really like IE, you can do that. I recommend Firefox and IE, or Firefox and Chrome. It's the easiest way to separate what you're doing, because you don't want to clog up the proxy with all of your Google searches and research that you're doing while you're testing. You want your proxy logs to be clean and only involve your hacking and testing. Any questions about that? Is that clear to everybody what we're doing? All right, cool. Another thing to remember is not all tests require a proxy. You can test for SQL injection, you can test for cross-site scripting. There are a lot of things you can do without a proxy. So don't use the proxy if you don't need to. Don't overcomplicate things. Where the proxy comes in handy is anytime there's client-side filtering, which is what we'll talk about in just a minute. So just to give you an example of things that you can do in your browser, this is one of the modules within WebGoat. So what we're looking at now is WebGoat, which is just running on my local machine. It's listening on 8080. I am currently proxying through Burp, which is listening on 8081. So everything I do in my browser goes to Burp, then it goes to WebGoat. And you can watch it all right here. But before we get to that, just generally using your browser, one of the first modules in WebGoat is to get you to familiarize yourself with certain functions that will allow you to examine the content that's been served to you in your browser in its raw form, right? So what they want you to do here is look at the source of this page and identify useful information that may have been left behind by the developer. Developers often tend to leave behind comments in source, and they forget to clean that up, right? So maybe it got left in a live production website. It's kind of a silly lab. It's really, really, really super basic stuff, but they just want to introduce you to things like, I'm going to call it out yet because I'm going to ask a question. Anyone want to fill us in on what we would use to view the raw HTML in this web page? Got some developers in the room, right? So it's inspect element is just what they want you to become familiar with. So they want to get you to use inspect element. They give you, so all of these labs from WebGoat and Security Shepherd, they always give you some hints up here, some very basic information about what the lab wants you to do, the goal of this hacking exercise. You can show hints, you can flat out show the solution. I strongly advise you to give these things at least 15, 20 minutes without doing that, because that's the best way to learn. So in this one, the hints that they've given you are statements like fix me and to-dos, right? That's a pretty glaring hint. So if we inspect element and we just search for to-dos, not anything interesting there. So we'll try fix me. And hopefully you guys can read that. If not, feel free to move closer. But basically, the developer just left behind a user ID and password. So it's overly simplified to make their point in WebGoat. You probably wouldn't see this in real life. Usually the juiciest thing we get in HTML source is a developer name, phone number, email address, something like that. So could be useful for a social engineering attack, something along that nature. But then again, the flip side of that coin is, we live in a world where Mark Zuckerberg's password is DA, DA, DA. So you never know. Just bear with me while I Alt-Tab back and forth. So let's talk about the basic use of Burp or any proxy, really. Generally, you're going to have a tab that shows all of your history. All your gets and posts will be outlined for you right here in a window. Anytime you select one of those, you'll see the raw gets, you'll see the raw posts. In the terms of a post, you will see, let me just find one for you. You'll see all the post field parameters.
So this is all coming from your local machine from Shepherd? Or from, so you downloaded the Shepherd webpage on your local machine?
Yeah, pretend Shepherd is a website that I'm hacking.
Sure, but it's not. It's a local thing you downloaded on your box. Right?
I'm running a web server on this laptop, yeah.
Okay. So this is what Burp is, the analysis of that website through Burp.
Mm-hmm.
Okay.
Exactly. And one of the nice things about Burp is you can sort by which gets and post had parameters. So I can look at wherever there is an opportunity for me to manipulate a parameter. You can look and see all of the pages where you have actually made changes. So I can sort by everything that I have attempted to hack. Once you select one of those, let me find one for you that's edited. You get an extra tab down here. You'll get the original request, and then you can look at your edited request and see what you did in case you forgot. That sometimes happens to us. And then you can see the raw response from the server if you want to go back and look at that as well. So all of that information is available for you right here on Burp in a nice clean format. And let's get over to WebGoat now. Okay, so we want to get to bypass HTML field restrictions, because that's the basic function of a proxy, is to do exactly that, bypass local JavaScript restrictions on the input that I can send to the web application. So in WebGoat, that's under parameter tampering, bypass HTML field restrictions. So basic a restriction would be I give my users a drop-down box, I give my users a radio button, a checkbox, I give them a field that's restricted to only numbers or only letters, or maybe it's a zip code and it's restricted to only 5 numerical digits, right? Usually all of that is handled locally in the browser, and you can't rely on that as a developer because attackers are going to bypass any restrictions that you give to the browser because it's too easy to bypass them. I could literally edit the source and remove the JavaScript, or what's more easy is I can just use a proxy to bypass all of those restrictions. And why are those important? Well, a very simple example that doesn't happen much, but 10 years ago when we were testing online banking applications, we log into the online bank, we go to transfer funds, and there's a drop-down box that says from, and I select my checking account, and there's a drop-down box that says to, and it's my savings account, my checking account, and my credit card, and I select one of those, I capture it in the proxy, and I change the to field because the developer was, I hate to use the word lazy, but I guess I will. The developers decided to seed all of those drop-down boxes with actual routing numbers and account numbers instead of a reference that would be looked up in a database, right? So I have static values that I can now edit, and 10 years ago we were transferring money all over the place because of these assumptions. So how do I bypass these restrictions with a proxy? Pretty easy. Go over to Burp. Currently, we're in the history tab, which is what we talked about. We want to do our work here in the intercept tab. So we turn intercept on, go back to our browser, hit the submit button, which performs the post, which gets captured here in Burp normally. Don't you love live demos? Hold on a second. I'm going to reset the lesson. Okay, intercept on. I'm going to select whatever. Submit that. Go to Burp. Okay, and there are all my form field parameters. And Burp lets you look at it in raw in parameters like this. Some people prefer this view, whatever suits your needs. You can see just the headers. You can see it in hex. I generally tend to work in raw. And while we're here in intercept, all we have to do is drop the cursor down into the form field parameters, and we can make any edits or changes that we want. So the goal of this lab is to submit invalid values for all 6 fields in a single form submission. So they want us to bypass all the local restrictions here and submit totally invalid data to the web application to see how it responds. That's just hacking 101, step 1, in determining how well your app is going to handle an attack. So that's pretty easy. I can really just put in anything here. It just has to be something that they're not expecting and not allowing. So that's 3, 4, 5. Now notice they said 6 fields. So what am I missing? I'm only at 5. Sorry? So there was one more. So only 5 are showing up here in Burp, right? But the lab wants me to submit 6 values. And yes, submit is one of them. Any guesses? So there's a form field parameter called disabled, which means I either need to go back to inspect element and change disabled to enabled, or what's actually easier is just find the name of this field, again with inspect element. Could be disabled, could be something else, right? What's the variable? Why do you keep putting a dot there? So rather than dig around in here, I'll just tell you that the name of the parameter is disabled input, all one word. So I just have to add that. And just to be safe, in case it's parsing and dropping the parse after it sees submit, I'll put it before submit. So I'm going to add disabled input equals foo, and then you just click the intercept button off. It will forward that post onto the web server. Let me close inspect element. And normally you get a green thing here that says you successfully completed the lab. So I probably fat fingered something or whatever. I don't know. We can try it one more time. I'll just do intercept, submit. Yeah. So WebGo can be a little buggy sometimes, and because this class was structured a few months ago, this is actually an old version of WebGo. They're up to version 7 now, which is a completely revamped interface. It just came out. It's a little more slicker, and they fixed a lot of the bugs. So you'll be working with the new version if you decide to download this at home. So any questions about the basic use of Burp or bypassing local HTML form restrictions? Pretty straightforward? Cool. So we'll get a little more advanced as we go along. Another thing you can test for is poor data validation. I would recommend, so we'll show you some Security Shepherd now and the differences between that and WebGoat. So let's go to Security Shepherd, Field Training, Poor Data Validation. Okay, I'll log back in. So poor data validation is anytime you're expecting a particular format or value and the end user gives you something else. A very basic example of that would be a positive number versus a negative number, or a number versus a letter, or dangerous things like single quotes, semicolons, right? There are a lot of cases where you don't want those because those are the keys to cross-site scripting and SQL injection. So, 10 years ago, we were hacking shopping carts, putting items in shopping carts, changing the prices of those items, buying the items for greatly reduced prices, right? Everybody caught on to this. This really I haven't seen this vulnerability in over 10 years. But one thing that we did see, it was about a year and a half ago, was a shopping cart. And of course, we do our due diligence. We will attempt to modify, manipulate the shopping cart. We tried to change prices. They were tracking it on the server side. They knew what we were doing. They stopped us. None of that worked. However, we try to be thorough. We test every field. We test every area of the website. And what we found was they were doing their job on quantity, cost, subtotal, total. All of that was checked and tracked, but they overlooked the tax field. And we found that if we put a negative number in the tax field, we could greatly reduce the price of our merchandise, which was very nice. Negative $5,000 tax on a $6,000 computer works out pretty good for us. So how do you do this? Because the app itself isn't going to just let you put in a negative number. And if it's a shopping cart, it's calculated, right? There's no way for you to actually ever submit a negative value without the use of a proxy. So we start with something that's allowed, capture it as usual. And then just change that to negative $5,000 or whatever we're trying to do. And the way Security Shepherd works is it's kind of a capture the flag kind of thing. It has a point system, and anytime you get a lab correct, they give you this key here. You put the key up into this field up here, and when you have so we do this in a classroom environment. It's a 2-day class we walk through all of the criteria in OWASP. So all the students get a score on a centralized scoreboard, and they can all see how they're doing. Since it's just me, I don't really need to give myself the points, so we won't bother. But you got it right once you get that result key down there in Security Shepherd. Any questions about that? How many people are familiar with insecure direct object reference? So insecure direct object reference is the ability to ask for a resource that the web server normally offers as its normal course of business that doesn't belong to you. So a simple example would be if you're the retirement system and you provide your members with annual reports, they can log in, hit a button, get a copy of their annual report. Insecure direct object reference would be the ability to look at the annual report for another user of the system logged in as yourself. That's a basic example of what we call IDOR. And how do you test for that? Well, it depends on how that resource is being identified, right? Are you straight up calling the PDF, which is a horrible thing to do, and we have an example of that in a second. Is it a reference number? Is it like an MD5 hash, and can I brute force MD5 hashes? How are you serving that resource is the answer to how you test for it. So let's look at this example here. Field training, insecure direct object reference. Alrighty, so first thing you want to do is read the lab, figure out what they're trying to get you to do, and then try to figure out how to execute the hack. So they're basically saying that the key to complete this lesson is stored in the administrator's profile. So you're logged in as yourself, and you can just refresh your profile and look at yourself. And what they want you to do is go retrieve the profile for another user, in this case, the administrator. So the first thing that we do when we see something like this is just kind of baseline this and figure out how are they calling up this data about me, right? Are you reading a session token, a session credential, which would be the correct way? Or is there some sort of URL parameter or form post parameter that you're trusting me to tell you who I am, which is the wrong way to do it? So let's see how it is in this case. We'll intercept it. We'll refresh our profile. And so they're doing it very poorly. I'm just telling the server who I am, which is something you never want to do. And I'll just put in other user's name there, right? In this case, I believe we're after admin. So I would try admin, administrator, super, various permutations of anything related to admin. So that got us for us. That one was pretty straightforward, pretty basic. And understand all the examples so far, these are all this is all the introductory areas of Security Shepherd. When you get down into Lieutenant, Major, and Admiral, so if you go home and download Security Shepherd and you are able to, without cheating, complete Lieutenant, Major, and Admiral, please give me a call because we would like to hire you. They get ridiculously complicated. If we have some time at the end, I'll show you one of these. But some of these can literally take 15, 20 minutes to execute just on their own. But yeah, please do look at these because they're pretty fun. Any questions on that? All right, so we'll look at one that's a little more complicated. Session management number 2, still under private. Well, at least we're beyond field training now. So I think it said session management 2. Pardon my terrible scrolling. I think it's this one. All right, so this website apparently has an administrator-only function that only administrators can access. That when we try it, it just checks our credentials. It's doing some kind of check and deciding we're not an admin. So again, how is it doing that check? So we would baseline it to start off with and see if we can figure out how that check is performed. So upgrade user to admin, false. Let's make that true. That looks like a pretty fun one. Nope, didn't work. Let's see what else we have to play with. We have admin detected equals false. Let's change that to true. Return password. Let's change this one to true. Do them both at the same time. So now their IDS has determined that we are parameter tampering, and we've set off some sort of alarm, which is not good, but that happens. Let's refresh that. That's clearly not the right way to go. And session management, that's where I was, right? Yeah, all right, my administrator only button. Let's look at that again. So I have some cookies, which we talked about a second ago, which if done correctly, that's how you should be determining who I am to determine what I'm allowed to see. But there's good ways and bad ways to do that. Let's see how this site is actually doing it. So I would just start with the very first one. So JSessionID is a very well-known cookie. It's built into Java, right? I already know this cookie is sufficiently random and hardened and non-brute forceable. It's not rainbow tabled. I know that there's nothing I can do with a .NET session ID. I know that there's nothing I can do with a JSession ID. They are known good entities. This token, I don't know what that is. Maybe we play with that. But I've got two values here that are very obvious. What? Anyone? Those are base 64. We know that just because of the makeup of this. It's full character set, it's upper and lower case, and these double equals are indicative of base 64 as well. This I can recognize as an MD5 or some derivative of MD5, and know that the hackers that are attacking your site can look at these, and in 2 seconds they know that's triple DES, they know it's MD5, they know it's MD4, they know it's SHA-2. We know just by glancing at these what they are, just from experience. So let's see if we can figure out what that is. We'll take that value, and another feature of Burp is it has a decoder built in. So I can just paste this value in here, and I can tell Burp to decode that as base 64, since I know it's base 64, and I got nothing. Let's try the other one, because we had 2 in here. We had a J session 3. These are so hard to grab. I'm going to do it this way. Take that, put it in the decoder. And that does not look like anything useful either. Any ideas? So there's something that became popular quite a while ago. So I'm going to take the first one, decode it. This I don't think this one is a double decode. I think I fat fingered it the first time, but let's talk about that. So when these types of attacks first came out 8-9 years ago, developers started normalizing, canonicalizing, and decoding to try and mitigate against these types of input validation attacks. Unfortunately, so say for example, I'm trying to do cross-site scripting and I want to send a greater than with some script followed by a less than. So they would encode the greater thans so that they wouldn't be interpreted by the web browser later, thereby defeating the cross-site scripting attack. Well, we responded to that by double encoding, which meant then the developers had to resort to double decoding, and it's a multi-headed hydra, right? It's not the right way to mitigate against cross-site scripting. So anytime you see a base 64 or something that you want to decode, always go for at least triple, just to see. So that's what we do. In this particular case, once we decoded the base 64, we saw some plain text that gives a user role, and that's in a session credential, right? That's in a cookie, so that's the wrong way to do a cookie. A cookie, you should be using JSession or .NET, not something you made up yourself that's easily reversible into clear text, and once it's reversible, it's manipulable, right? So I'm just going to change this to admin, and then I'm going to encode it as base 64. I'm going to grab that into my paste buffer, go back to my proxy, oops, replace the cookie that's already here with the one that represents admin, send that onto the website, and normally that would work. Want to try again? Of course, it could be administrator, right? You got to play around with these things. Let's try that actually. You can also right-click on these and send them directly to the decoder. So let's try administrator spelled out. Back to the proxy. I know you're thinking I could have just right-clicked that, but unfortunately it doesn't work. There you go. So that's what they wanted. An administrator filled out. Questions? Alrighty. So let's look at number 3, and we're up to Sergeant now. All right, so what they want you to do here is log in as admin. Only an admin can retrieve the key to complete this challenge. You're just a regular user, and you don't have access to the admin account. However, there is a function for changing your password, and they've committed the #1 most basic offense on a self-service password reset screen, which is not asking for current password on a password change. So this is one of the reasons why you must always ask for current password whenever you allow a user to change their password, because we can do fun things like this. So let's see what this looks like. I'm typing the word test to make my password test. Local JavaScript wants me to make it longer. Okay, I'll add 1, 2, 3, 4. All right, so I've got a new password, and I've got that same cookie again. So what if I grab that cookie, send to the decoder, decode that. Oh, there's that user again. So now, did they say administrator or admin? They said admin. Let's try that. So let's change ourselves to admin. Grab that. Yeah, it puts it up there for some reason. I can't Control V without reselecting it. Send that on. And then I'll log in as admin, and I just hopefully changed their password to test 1, 2, 3, 4. Nope, so it might be administrator or again. Questions?
So how do you know, I mean, it seems like these labs kind of guide you through certain drills. How would you know what to do in a regular web environment? If I just went to CNN and I wanted to...
You want to start collecting some bug bounties?
Yeah, exactly.
Sure, good question. Test guide. So OWASP has a project called the Testing Guide, and their search engine is actually terrible, so let's just do this. You can get it, well, you used to be able to get it as a PDF. I think it's just a straight live wiki now. So there you go. And this will walk you through pretty much all of the, I don't know, there used to be about 120 of them, all of the tests that you need to perform on a transactional web application. So this guide will walk you through, how do I test for SQL injection? How do I test for cross-site scripting? How do I test for insecure direct object reference? How do I test the session credential? How do I test the authentication functions on the website? How do I test the security configuration of the web server? Pretty much everything you need to be worried about at the app layer for a transactional web application is covered here in this guide. And if you're a developer, they also have a development guide on how to develop secure code. So, you know, what are some basic rules about use of cookies? Those are in the developer's guide. What are some basic rules about a good password self-service reset function? Right, those are in the developer's guide. Don't ask people what their favorite color is, right? These are terrible questions. Did that answer your question?
How do you know which pages, CNN or whatever, this stuff applies to?
Anywhere that you've logged in and you are retrieving interesting or sensitive information in kind of transactional web application, right? So we have till 4:15. We got 5 minutes left. We can just go to questions. Any questions? The rest of the slides are just a couple other examples on how to, basically use Burp. And then, that was just the very, very, very basics. There are 100 different things you can do with Burp, and like I said, we have an actual 2-day class on how to use Burp, including all the advanced functions.
So I think that that's your favorite tool, Burp.
Yeah, definitely. Yep, the Pro version. The Pro version's only $300,
Yeah, it's not that expensive.
right? Yep.
So what are the major hackers that are hacking into DoD systems and so on? Are they using multiple other tools that exist?
Well, if they're coming at you from the app layer exclusively, they're going to be using Burper's app. Yep. You know, they might stick another proxy in front of it to remove the signature, right? Just in case you're logging or you've got a good IDS. They might want to change headers. So Burp makes it, so any browser that connects to a web server identifies itself, right?
Yeah.
Burp identifies itself as Burp. And depending on how far, you know, up or down you've got your knob set on your IDS might complain that someone just connected to your website with Burp, right? Or you might get that alert and ignore it, so yeah. But those are the tools they use, yes. Now, if they're coming at you from other layers, you know, other angles, you know, they're going to be using things like Nessus, homegrown tools, their own Perl scripts. Yeah, yeah. Metasploit. Our favorite tools are Nessus, Metasploit, and Burp. That covers 90% of what we need to do during a pen test, those 3 tools.
So would a hacker use these tools and then try to forward their Burp requests through a Tor?
They could be doing all of this behind Tor, yes.
To try to obfuscate?
Yeah, absolutely. So in Burp, in fact, Burp even has a provision for you to do this. So under its configuration,
You're on film, right?
when you're setting up the options, yeah, I'm cool with that. You can set Burp itself to then proxy through another proxy as well. And that could be Onion. So I can go my browser, Burp, Onion, you. Right? And that way you won't be able to identify the source of the attack. Other questions? 1 minute to spare.
Using your own discretion.
Go get some bug bounties. Thank you very much.